Let's look at a couple examples of finding the magnitude and direction of a vector. In this case, when we think about direction, we're just going to try and find the angle of the vector in standard position. So that'd be an angle between 0 and 360 degrees. In this example, we're given a vector graphically where its initial point is at the origin and the terminal point is at the coordinate -2 square root of 3, comma 2. So if we wanted to write that as sort of as a vector in component form, we'd have v, well, I'll just use v for vector. V equals, inside the vector brackets, a -2 square root of 3, comma, a +2. All right. So that's what our component form looks like. Again, since the vector started at the origin, the component form corresponds to the same values as the actual terminal point's coordinates. All right, so to find the magnitude, remember magnitude of a vector is just the horizontal component squared plus the vertical component squared, and then we take the square root of that. So it's the square root of a squared plus b squared. And to find the direction, we can use tangent. So the tangent of theta is equal to the ratio b over a. All right, again, b is the vertical component. So in this case, b is a 2, and a is the horizontal component. So a is going to be that -2 square root of 3. And again, all of this is a result of just right triangle trig. So if we took the vector from the origin to -2 root 3, comma 2, and we drew sort of a little vertical line down from the terminal point down to the x-axis, it creates a right triangle. And so the a is the horizontal part of that side of that right triangle, b is the vertical side, and theta is the acute angle inside the triangle at the origin. Okay, so it is literally just right triangle trig that we're using here. Okay, so let's start with the magnitude. So the magnitude of our vector is the square root of a squared plus b squared. So that's going to be the square root of a -2 square root of 3, all of that squared, plus a 2 squared. All right, when we square root a -2 times the square root of 3, or sorry, when we square a -2 square root of 3, we're going to square the -2, and we're going to square the square root of 3. So a -2 squared is 4, and a square root of 3 squared is just a 3. So we have 4 times 3 plus the 2 squared, which is 4. So 4 times 3 plus another 4. So that's going to be 12 plus 4. So that's we're going to have the square root of 16, which is 4. So the magnitude of this vector is 4. And to find the direction, so we have the tangent of theta is b over a. And again, b is 2. A is a -2 square root of 3. And the 2's are going to cancel. So we have tangent of theta is equal to a -1 over a square root of 3. So we can use our right triangle trig. We can use our unit circle to figure out what theta is. So tangent is a 1 over square root of 3 at any of the pi over 6 angles. Okay, so pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. But 2 of those are going to be positive, and the other 2 are going to be negative. Remember, tangent's positive in the first and the third. It's negative in the second and the fourth. And if you look at the vector that we had, it is pointing into the second quadrant. So I need the pi over 6 angle in the second quadrant. And so theta is going to be 5 pi over 6. Okay, so we have a magnitude of 4 and a direction angle of 5 pi over 6. So I said we're going to do that in degrees. So 5 pi over 6 is the same thing as a 30. So that would be 150 degrees. All right, let's try one more here. This time we have our vector. Its initial point is at the coordinate 2, 2. And its terminal point is at the point -3, -1. Okay, so it's going from 2, 2 to -3, -1. And so that is going to have a horizontal component. So it's traveling a distance of 1, 2, 3, 4, 5 units to the left. So the horizontal component's a -5. And the vertical component, it's traveling down 1, 2, 3 units. So the vertical component is a -3. So the component form for this vector, I'll just use V again. Our component form of this vector inside vector brackets is going to be -5, -3. All right, so we're going to follow the same process to find the magnitude and the direction. So the magnitude is the square root of the a squared plus the b squared. So it's going to be the square root of a -5 squared plus a -3 squared. And so a -5 squared is 25. A -3 squared is a 9. So we're going to have the square root of 25 plus 29, which is going to be the square root of 34. And the square root of 34 is approximately 5.83. All right, so that's the magnitude of this vector. All right, to find the angle, again, we're going to do the same thing. The tangent of theta is b over a, so it's going to be a -3 over a -5, which turns out to just be 3/5. Right? The double negative makes it a positive 3/5. 3/5 is not one of the nice unit circle values that we want. And so how do we figure out what the angle is if it's not a nice unit circle value? Well, we're going to have to use an inverse tangent. So theta is going to equal the inverse tangent of a positive 3/5. And again, that is the exact answer, but if we wanted to get a decimal value for this, we can use our calculator. So the inverse tangent of 3/5 is 30.96 degrees. Now that 30.96 degrees, remember that's pointing, if you think about our unit circle, that's pointing into the first quadrant of the unit circle. But our vector is pointing down and to the left. So it's actually pointing, if you, again, kind of think in terms of unit circle, it is pointing down into the third quadrant, which again, remember, tangent is positive in the third quadrant. So how do I find the angle that is in the third quadrant? Well, tangent, remember, is sort of symmetric here. So if I take that initial angle I found, that 30.96, and if I add 180 degrees, then it will give us the exact opposite. So if I take that 30.96 and add 180, I will get that theta is going to be 210.96 degrees.